All right, so this is worksheet 9. You should also have out worksheet 8.5 because it has some examples and it's a great reference sheet to follow. Did everybody find both of those things? Okay, so we're going to talk about rational functions today, which look like these crazy things. Does anybody remember talking about top heavy, bottom heavy, and equal weight last year? Okay. You all, whether your teacher used those words or not, you all should have done some rational functions in Algebra 2. So you're going to have to be able to eventually sketch. Friday's quiz does not have sketching. It just asks you to identify zeros, vertical and horizontal asymptotes, and holes. Eventually, you're going to have to do oblique, another end behavior asymptotes. I think there's actually one on Friday's quiz. So a rational function is just a quotient of two polynomial functions. So you put a polynomial function on top of another polynomial function, and you get this messy rational function idea. The domain, as always, is all real numbers except those that make the denominator equal to 0. Now, today we're going to find out that those places that make the denominators equal to 0 are also either going to be a vertical asymptote or a hole. I need you to understand that while we say x cannot equal 7 and then we proceed to say x equals 7 is an asymptote, the reason that is because the asymptote is actually not part of the graph. The asymptote is simply a boundary. Okay? So it's going to be where it's undefined. So that's why we say can't equal x, and then we proceed to say there's an asymptote at x equals x, 7 or whatever it is. All right. The end behavior of the function off on the far left and far right. I'm going to take a commercial break here. Guys, how do you say far left? X approaches negative infinity. How do you say far right? Okay. If you want to talk about what it's doing on the far left, then you say the y is, in this case, approaching 0. Okay. And actually on the far right, this one is also approaching 0. But I got some of you on the quiz who are giving me like this answer. This would say on the left it's approaching 0 and on the left it's approaching infinity. The x has to be different, guys, and I don't know how to help some of you anymore with end behavior. All right. That was just a commercial break from the quizzing. All right. Does everybody have the little yellow sheet you picked up? I think all of this is right off the little yellow sheet. And you get to use this on the quiz. You get to use this on the final. Okay. I will tell you right, and you can write on this one, because I will tell you right now the day of the quiz and the day of the final, I'm going to hand you a brand new one, okay? I have a blue set just for taking the quiz, because I don't want, if you feel like writing extra stuff on yours, that's fine, but the one I give you for the quiz isn't going to get to have extra stuff on. Does that make sense? All right. So the idea is you need to factor first the top and the bottom of any rational function. Then we're going to look for the domain restrictions and the vertical asymptotes. All right. We're going to look for x-intercepts and y-intercepts. Let's talk about this part down here. An x-intercept is anything that will make the top equal 0, the numerator equal 0. Does that make sense? If you have a fraction, the only way to make it equal 0 is for the top to equal 0. Hope so. The y-intercept is the same as it's always been. The y-intercept is what happens when x equals 0. So you plug in a 0 to find out if it has a y-intercept. All right, then this business about horizontal asymptotes or end behavior. And I'm gonna show you some examples on another slide. I won't spend time on, I'm on this slide. Okay. For that section, if you have the degree, okay, we got some confusion about what degree is. What is the degree? So what's the degree of the top right here? The highest exponent power. So this is degree 1. This one down here is degree 2. So therefore, the numerator has a smaller degree than the denominator, okay? This is called bottom heavy because it's got more x's in the denominator, higher degree, okay? When it is bottom heavy, the end behaviors, in other words, when you put in really big numbers, think about this, guys. If I put in 1,000, on the top I'm going to have 1,006, right? But if I put in 1,000 down here, when I square 1,000, I get like 1,000,000. So it's going to have a way bigger number on the bottom. So what's that going to happen when you have a way bigger number on the bottom of a fraction? If I have 1 over 100, what do I get? It's a really little number, right? Does that make any sense? If the bottom is a lot bigger than the top, it's going to approach 0. So the asymptote for bottom heavy is just y equals 0. All right. This one is degree what on top? Degree 2. On the bottom we have degree 2. That's what's called equal weight. When they're equal on the top and the bottom, if we put in 100,000, a really big number, and we square it and then we divide it by the same squared thing, all that's going to be left, all the rest of this is going to kind of fade away into nothingness, and you're going to end up with the leading coefficient over the leading coefficient. It says it will approach y equals c, where c is the ratio of leading coefficient of the numerator and denominator. So this would be 2 over 1. This would have a horizontal asymptote at y equals 2. This one was at y equals 0. All right, degree of the top over here, guys. Degree 2. Degree of the bottom, degree 1. This is called top heavy. Degree of the top is greater. The issue is, in Algebra 2, when it was top heavy, you got to just say there was no horizontal asymptote and be done. In pre-calc, you're going to have to find an end behavior equation. And to do that, we're going to talk about this down here at the bottom. Okay? It says the end behavior asymptote will be the quotient polynomial ignoring the remainder. So you'll have y equals the quotient polynomial. So if I go back real quick to this example, it's going to be y equals what I get when I divide this. Okay, the quotient of this. Can I do synthetic division if my bottom factor is x plus 3? So if I put a negative 3 here across the top, I'd have 5x squared, 0x though, right? And a negative 125. I bring down the 5, I multiply, I get negative 15, I add, I get negative 15, multiply, I get 45, add, and I get negative 80 maybe. But what did it say about the remainder? Ignore the remainder. So this would have an asymptote that was oblique or at an angle of this, which is what? Equation. Y equals 5x minus 15. So if I graph that line, y equals 5x minus 15, that's what this equation would look, this rational function would look like. All right, so that was an overview of everything on the reference sheet. We're going to start with a quick example here. It says, what is the domain of this function? Guys, I don't know that you have this one. Just tell me, what can x not equal? We've been doing this all year. X can't equal 3. And I will let you write that. You don't have to write in an interval notation, okay? You can just tell me it's everything but 3. The equation of the vertical asymptotes. They have to be equations. The vertical asymptotes here are the places where the graph is undefined. So it's just at x equals 3. But it is the equation of this line right here, x equals 3, that is a boundary to the graph. All right? What is this in terms of top heavy, bottom heavy, equal weight? It is equal weight, so the leading coefficients were 1 and 1. So the rule is you take y equals leading coefficient over leading coefficient, so you'd get y equals 1. That's the equation of this line right here. Now, There's something weird about horizontal asymptotes. It is possible for a graph to cross a horizontal asymptote. Okay, can never touch or cross a vertical, but it can cross a horizontal. This one does not. It just approaches that behavior on the ends. So as for the directions for this question, you would say x cannot be 3. There's a vertical asymptote at x equals 3 and a horizontal asymptote at y equals 1. There are some on the homework where it doesn't even ask you to graph. That's all it wants, is that information. All right, you have this one on your paper, your notes. I think it's done for you. Real quick, the domain could not be -3. So it had a vertical asymptote at x equals -3, okay, which is this line right here, going up and down. It has to be an equation because it's a line. It's not a point. What about the weight of these? Equal weight, but leading coefficients were what? 2 over 1. So we have y equals 2 is this line is the horizontal asymptote. Then to figure out the intercepts, okay, what did we say about intercepts? How do you find where it crosses x? Yes, you plug in a 0 for y, but what that means is you have to make the whole thing equal to 0. And what's the only time this function is going to be equal to 0 is if the top is equal to 0, right? So what would make the top equal to 0? Okay, so at 1/2 0, this should be crossing the x-axis here. That's the x-intercept. And the y-intercept is when what? X equals 0. So if I go back here and plug in a 0 right here, I'll have 0 minus 1, which is -1. Down here, 0 plus 3 is 3. So 0, -1/3, which is right down here. It's really not a good graph, but it does list those. I wanted to make sure we talked about how they found those. All right, so we're supposed to do this one. Do you have this one? You don't? X plus 2 over x times x minus 6. The bottom of the front. Okay, it has a graph paper. Everybody find it? All right, determine any asymptotes. State its domain. Let's do the domain first. The domain is all real numbers except x cannot equal. Be careful. What two numbers would make the denominator 0? X and x minus 6 equals 0 means there's a 0 at this or this. So we have 0 and 6. Now, those are things the denominator cannot equal, and we have to state them that way. But then we're going to proceed to say, therefore, there are vertical asymptotes at those same places, x equals 0 and x equals 6. Now, I will tell you, it's not always true that there's a vertical asymptote there. Sometimes there's a hole instead, and we're going to talk about holes in a minute. Okay, a hole in the graph is when there's a common factor to the top and bottom. Is there anything, the same factor? Is there anything we can reduce on this one? No, that's why there's not a hole. All right, x equals 0 is the y-axis. So there's an asymptote. X equals 6 is this line over here because they're counting by 2's. So there's an asymptote. Anytime you have two vertical asymptotes, there are 3 parts to the graph. And you have to look for them. Sometimes they don't show up on the graph when you just do a zoom 6. There's something happening to the left of 0. There's something happening between 0 and 6, and something happening to the right of 6. Make sense? Okay. Now we're supposed to find, is there horizontal? Is this one top heavy, bottom heavy, or equal weight? Yeah, we got to be careful because it's factored for us when we started, but it has an x plus 2, and if we FOILed the bottom, we'd have, or distributed, we'd have this. So it's degree 1 over degree 2, which is bottom heavy. And what's the rule for bottom heavy? Yes, anytime you're dividing by more x's, they're going to cancel out, and you're going to have a horizontal asymptote at y equals 0. which is the x-axis, going this way. So out on the far ends, if you had to describe the end behavior, you would say this is approaching 0. All right, what about places it crosses the x-axis? It's whatever makes the top 0. X plus 2 equals 0. We'd get -2, 0. So -2 would be here. Now that's weird. We have an asymptote and we just put a dot right on the asymptote. Okay. It's possible, remember, that it could cross a horizontal asymptote. Can't cross a vertical, right? All right, what about a y-intercept? If I put a 0 in here, what will I get? 2 over 0 times -6, which is 2 over 0, which is undefined. Does that make sense? If this is an asymptote, we can't cross it or touch it, right? All right, yes.
So then will all the y?
No, because they don't always, anyone that had a plain old x in the denominator, yes.
Okay.
But otherwise, if it didn't, then no. All right, good question. Now, guys, if I was going to ask you to graph this on a quiz, I would let you have your calculator, okay? At no point are you going to have to graph one of these without a graphing calculator. The thing to be careful of when you type this one in is you have to type parenthesis x plus 2, close parenthesis, divided by parenthesis, x times the quantity x minus 6, close. You have to always put an extra parenthesis around the top and the bottom. All right, you can type it in if you want. I typed it in. I got this as a Zoom standard. How many of you would have said it ended here? Okay, these don't have ending points anywhere. Okay, so I turned the axes off just so I could see a little bit better what was going on. It's also good sometimes to zoom in or zoom out, and we'll practice some of this. I just don't have time to go through all the options today. Okay, so this shape was telling me that it came here. I should graph this one with you because did anybody graph it? Nobody? I'm thinking that it actually crosses the axis and stays just below here. Okay? That it's staying just below that it does become a little bit negative. And you would just trace out there to see. All right, then this like funky shaped parabola thing is somewhere in here. And we should probably find at least one point so that we could graph it fairly accurately. Are you working on this? Okay, Vaughn. And then over here we have this craziness going on over here. I'm not going to be super worried about accuracy on these, but if it crosses the x, I need you to show me that it crosses the x, etc. Did you get it graphed or no? Did anybody? Does it, if you trace over this way, does it become negative? Was my first question. Yes? Okay. Can you see if you can like put in a 1? Just do trace 1. Where is it at 1? Oh, so it comes really close here. Okay, great. Negative 0.6 means it actually comes really close to actually touching up there. That's what I wondered. Okay. Those are really my only questions. If you trace off to the right, it doesn't ever become negative, I don't think. You don't have to trace too far, but does it stay in positive? It doesn't have another x-intercept, so I don't think it's going to cross x again. All right. This is a bit different of a question, and this again has what's called a cusp point when you get to calculus, how it reaches a peak here. The only thing I want us to look at, is this denominator ever going to equal 0? Oh, that was another thing that happened on the quiz. Some of you tried to factor things like this and wrote 2x plus 1, 2x minus 1. Does this factor?
No.
No, the sum of perfect squares does not factor. So it doesn't ever equal 0. Think about that. If you square something, it's positive, right? Times 4 plus 1. Even if you put a 0 in, you add 1, it's never going to be 0. So the domain is all real numbers, has no restrictions. And the top, is that ever going to equal 0? No, so it has no x-intercepts. What about end behavior? Is this top heavy, bottom heavy, or equal weight? Equal weight, where the leading coefficients are. So it is approaching y equals 2, which is this red line here on the graph. Okay? It does cross the y. How do you find where it crosses the y again? Yes. So if I put in a 0 up top, this would be 0, at bottom, this would be 0, and I'd just be at 5, right? 5 over 1. So this is 5. All right. That's kind of a weird one. Let's try, do you have these or not? No? Okay, I just want to talk about, because these, on 1b anyway, let's do 1a real quick together. What is the domain of this function? Oh, we should do what to the top first? Factor out a 3. Yes, factor should always be the first thing you try on these. We just haven't seen one that factored, I don't think, until now. Okay, so domain, vertical asymptote, horizontal asymptote, or end behavior. Okay, domain x cannot equal what because of the denominator? -5. Does that cancel that factor of x plus 5? No, so therefore it is a vertical asymptote. So if we were graphing this over here at x equals -5, we'd have a vertical asymptote. End behavior, is it top heavy, bottom heavy, or equal weight? It is equal weight. So we write y equals leading coefficient over leading coefficient would be, yikes. Okay, so way up here somewhere at 15, it would have a horizontal asymptote. Do you think that might be important to know before you tried to graph it? Because do we normally graph up as high as 15? No, so you're going to have to change your window. All right, what would make the top equal to 0? Right here. Anybody figure that out? If we set that top equal to 0, we'd have 5x equals -1, because the 3 would divide out. So we'd have -1/5. So it crosses x at -1/5. And does it cross y? What happens if you put a 0 in? The y-intercept, guys, you should be able to just eyeball this because this will go away if you put a 0 in, and this will go away, right? So you'll end up with 3 over 5. So it crosses right up here. So I'm thinking it does some loop-de-loop here and another loop-de-loop up here. And that's the issue that students don't see when they graph it. I'll go ahead and graph this one. 15x plus 3, is that what we started with? So I'm going to y equals, put parenthesis, 15x plus 3. Divided by, what was the denominator? X. Oh, you don't have this question. X plus 5. Thanks. All right. So if I do a zoom 6, I get that branch, which I would have thought I was done. Okay. But because there's a horizontal, actually because there's a vertical asymptote, I know there's another piece because there's always one on either side of a vertical asymptote. Because the horizontal asymptote is up at 15, I know I need to go up. So I'm going to go up as high as, we'll say 40. And I also need to go left more because I knew that it had the vertical asymptote at -5. I'll just try -25. I don't know. Okay. Yes. If you do a zoom 6 first, okay? And you don't screw it up. If you do a zoom, no, wait a minute. If whatever zoom fit does, it always leaves your X values what you set them, what they were. So doing a zoom fit at this point, okay, it changed, it's actually not bad for this one. The difference is, would you know that this is actually 15? Okay, it tends to make the Y's really extreme. If you look at the window now, okay, it left the X's -10 to 10, but it made the Y's really extreme. So the fact that if I go back here, we said there's an asymptote at Y equals, was it 5, guys, or 3? Y equals 15. Just kidding. Was Y equals 15. Does that look like it's at Y equals 15? Okay. So it's not really a very appropriate window. We probably could have made this -100 to 100 and it wouldn't have been horrible. Okay. All right. Good question though. A zoom fit will give you, for some questions, a better view of how to start. The issue, guys, is zoom fit never changes the X's. So if you have your X's set to something weird, your zoom fit won't show you all the graph necessarily. All right, I just wanted to show you this other one because it's what? Top heavy, bottom heavy, or equal weight? This is top heavy, okay? If I factor the top real fast, are there any factors that are going to cancel? Nolan, please stay awake. Any factors going to cancel here? No. Okay. Where is the domain restriction? X cannot equal -4. Okay. So does it have a vertical asymptote? Yes, at X equals -4, which apparently on my graph up here is over here. Horizontal asymptote, it does not have because it's top heavy, but you don't get to stop there. Okay. It says over here, nonlinear asymptotes are either oblique or what we're going to call an end behavior equation, come from doing what? We practiced it once already. To the very bottom of your yellow sheet. What does it say? Yes, you have to divide out. Now, can we use synthetic division here? Yes, we can put a -4 and the top would be 1, -1, and -6. Bring down the 1, multiply, add, multiply, remainder. What do we get to do with the remainder? Ignore it. So this equation is the end behavior, that's what that's called, end behavior asymptote is Y equals X minus 5. That's this equation, guys, where this is coming in right here. Okay? And then it'd have some zeros and so on. Let's go on and do one that you actually have. So the steps are to find the domain, sketch your asymptotes, find the intercepts, and then graph it on your calculator. For these, we aren't even asked to graph. You have these 3? Is this on the back? Okay, let's just talk about horizontal, vertical asymptotes and domain. That's all it asks about. Okay, does this have a domain restriction? Can this bottom part ever equal 0? No, because if you square something, add 1, it's going to be positive. So the domain is all real numbers. So does it have any vertical asymptotes? If the domain can, vertical asymptotes are what makes the denominator only equal to 0. Only the denominator, meaning if it made the top 0 as well, then it would be a whole. All right. Horizontal asymptote. Top heavy, bottom heavy, what's going on? Bottom heavy, so therefore it approaches Y equals 0. This is what you have to be able to do on the quiz Friday about this stuff. You don't have to actually graph it, okay? Number 2, does the top factor? Does any of it factor?
No.
Can I cancel any of it?
No.
No. The domain is all real numbers except what? X plus 1 cannot equal 0, so x cannot equal -1. The vertical asymptote, therefore, would be at x equals -1. The reason you say cannot equal is because it's not part of the domain. The vertical asymptote, remember, is not officially part of the graph. It's just a boundary. That's why it's the same place. All right. Horizontal or end behavior? Equal weight, yes. So it's y equals leading coefficient over leading coefficient. What's the leading coefficient on the top? And on the bottom? So we get y equals 1 as our end behavior equation. It's 2. It's 2. Just kidding. Thank you. Just making sure you're all awake. I'm not. Thank you. Good job. Do you want me to talk about intercepts real quick? Yes, they are. X-intercept is when the y equals 0, so the top equals 0. What would make the top 0? 2x plus 1 equals 0 would be -1/2. So that's -1/2, comma 0 is the x-intercept. The y-intercept is when you plug in a 0. So if I plug in a 0 up here, I just get what? 1, and on the bottom I get, so it has a y-intercept of 1. On this one, did the top ever equal 0? No, so it has no x-intercept. If you put in a 0, what would you get here? 4 over 0 plus 1, which would be 1. So the y-intercept was 0, 4. Does that help? You want me to do those so we practice all of that? All right, what about on number 3? Domain restrictions. Does anything cancel or need to be factored? Okay. Domain restriction is x cannot equal -1 or 2. And because nothing reduces, there's no holes, it has a vertical asymptote then at both -1 and +2. Those have to be written as an equation. You can't just list numbers. Okay. Top heavy, bottom heavy, equal weight. Bottom heavy means what? Yes, the end behavior or the horizontal asymptote will be at y equals 0. All right, if I put in a 0, I'll find the y-intercept. I'd get 3 over what? 3 over 1 times -2, wouldn't I? 0 plus 1 would be 1, 0 minus 2. So 3 over -2, or -3/2. Everybody okay? And how do I find the x-intercept again? The top has to equal 0. Yep. So if I set x plus 3 equal to 0, I'd get -3, 0. All right. I practiced end behavior a little bit. We'd have to use synthetic division. Again, 2 vertical asymptotes mean that there's 3 parts to the graph. We talked a little bit about that. All right. When you have a no horizontal asymptote, you are going to now be required to find that end behavior by division, and it's going to be called end behavior or an oblique asymptote, just so when you hear that phrase. I am going to skip so I can talk about holes just a little bit. When the numerator and denominator of a rational function have a common factor, then there is a hole, okay? So if this had the same factor top and bottom, it is called removable or non-removable discontinuity. It depends. Non-removable, guys, I think I'm saying this right. If you saw this, you could divide these out, but you would say it's undefined at 3 something, it has a hole. Okay, that's a removable discontinuity. Non-removable would be if you had more of them one place or the other, then only one of them would cancel. Okay, so we're not going to have those kinds, just telling you right now. All right, this is off 8.5. One side of 8.5. Some of you would like this. It's kind of a play-by-play about how to do these, okay? It says factor the numerator and denominator. If you have any canceled factors, they're wholes. You set the canceled factor equal to 0 and solve for x, and then you plug that number back into your new simplified equation. This is how to find a whole. Okay? So here's our example. Do you have one that has a hole? Maybe I should do the one that you have. Can go over the rest of this tomorrow. Oh, that's miserable. Nope, we don't want to do that one. I'm going to do this one that I have here. Real quick, if I factored this x plus 2, x minus 2, and down here it factors x minus 4 and x plus 2. What is the factor that's going to cancel? Okay, before you cancel it, you have to say x cannot equal 4 or negative 2. Is everybody clear on that? Once you have said that, it's okay to cancel this. There is not a vertical asymptote there. Instead, there is a hole. The hole occurs at negative 2 because that's what made top and bottom 0. How are you going to find this value back here then? You're going to plug it back in after you've canceled that. So if I plug a negative 2 into the top, what do I get? If I plug a negative 2 into the bottom, so the hole actually occurs at negative 2 comma 2/3. There is a whole question on Friday's quiz. We'll practice a bunch tomorrow, okay? The assignment tonight, I know we didn't get through all these slides, but this is what you need to be working on. Like, I think I looked at them closely today. I think the first 3 you don't have to graph at all, and the second 4 ask you to graph. Try practicing finding everything that it asks for, though, on the yellow sheets, okay? This assignment is also on the blue sheet, okay, that you got at the beginning of the unit, okay? Otherwise, write it down, take a picture, but it is on the blue sheet. It's listed as 2.5, like day 1, okay? See me if you need some help on some concepts on the quiz. Have a good day, guys.